One of the advantages to using Venn diagrams to display sets is conveying quite a bit of information in a very small amount of space. So when we're looking specifically at sets of numbers, it would be kind of wordy to try to label a number with all of its different categories. So for example, the number 5 is natural, whole, an integer, rational, and real. But rather than say all of that, if we have this Venn diagram in mind and we know how these categories work together, which numbers are subsets of others, then we can simply say that 5 is a natural number, and then conveyed by that is also the fact that it's whole, an integer, rational, and real. And we don't have to say all of that. All right, so if you're trying to categorize a number, often what we'll do is just categorize it by the inmost subset here. All right, so for example, if we're categorizing the number -8, okay, well that is certainly a real number, and it is a rational number, okay, because that can be written as a fraction if we just make that -8 over 1. Right? It is an integer, but it's not whole. Okay? It's not 0, 1, 2, 3, and so forth. Right? So if I'm trying to decide what to call the number 8, right, I would just choose the innermost circle here, and I would say that 8 is an integer. Oops. All right, let's do another example. How about the square root of 3? All right, well, this is a real number, and it is irrational. Right? So if you were to look at the decimal expansion of this, you would see that the numbers continue forever with no repeating pattern. Right? And that makes it irrational, and so it's not rational, and therefore, and then it's not any of the rest of these either. It's not an integer, whole, or natural. Right? So the best way to categorize square root 3 is to say either that it's real or that it's irrational. Either one of those would be fine. What about 0.6 repeating? Okay, so if you remember, that's the number 0.66666, and it just continues forever. All right, so another way to represent this would be as a fraction, and you may know that this is equal to 2/3. Right, and that means that this is a rational number. It's a ratio of two integers, and that means it's also a real number as well. All right, so if we're labeling this one, we would choose the innermost circle, and that's going to be a rational number. Let's do a fun one. What about the opposite of the square root of 4 cubed? Okay, so if you remember order of operations, we want to try to simplify this a little bit first to see what number this actually represents. All right, so if you look at the parentheses first, okay, the square root of 4, what is that? Well, that's 2. Okay, and then we want to take the opposite of 2 cubed. Well, 2 cubed is 2 times 2 times 2, so that's 8. And then the opposite of that is -8. Okay, so what is this number? Well, it's not natural, it's not 1, 2, 3, 4, etc. It's not whole, it's not 0, 1, 2, 3, 4, but it is an integer. And then it's also rational and real. Right, so if we wanted to categorize this, we could simply say that -8 is an integer, and then that would convey that it's also rational and real. Another thing you learned in your reading was the 4 standard categorical propositions. So here are the 4 different forms, and if you have a proposition that's not in this standard form, right, the way to rewrite this is to identify the subject set and the predicate set. So let's try another example of a statement that's not in one of these standard forms. So let's try all dogs have ears. Okay, so notice it doesn't have the word are in the middle, so we need to kind of rewrite it with that, right? And let's think through what the subject and predicate sets are. Right, so the subject set is there, that's dogs. Okay, and then what is the predicate set? Okay, there are a number of different ways you could phrase this, but let's maybe say, how about just things with ears? You could say animals with ears, but we just need to write it as a set rather than just that property of having ears. Okay, so then to write this in standard form, we would just simply fill in the words all and are. Okay, so we would say that all dogs are things with ears. Another example is the statement, some animals have tails. So the subject set here is animals. And then the predicate set would be things with tails. And then to write this in standard form, all right, we would fill in the words some and are. So some have, so this would be some animals are things with tails. Now let's try to represent this with a Venn diagram. All dogs are things with ears. All right, so we can use a rectangle to represent everything that we're talking about, and then we can use circles to represent the subject and predicate sets. So, all right, so we need to think through if these would be disjoint sets or if there would be any overlap or if one would be inside of the other. All right, so you learned that we can represent a statement that looks like this. The all of S are P, right? All of the subject set are in the predicate set. We can represent that with those nested circles, one inside the other as a subset. Right? So all of the dogs, that's a subset of the set of things with ears. Right? So let's make a circle for dogs. Right? And then we'll make another circle around that for things with ears. And I'll label that. Things with ears. Okay. And then it's up to you or the context what the rectangle would represent. So we might be talking about animals, it might be pets, it might be mammals. It depends on the context. What about the statement, some animals are things with tails? Well, this statement starts with some, so we know that we're going to have two circles that overlap, so I can draw those. All right, and then let's label these. All right, so one of these was animals, and one was things with tails. Okay, and I should be clear when labeling this, and I think your book attempted to do this as well, but when we write animals here, right, that is in labeling this entire blue circle. It's not just labeling this sort of moon shape of animals that don't have tails. Right? So in this textbook, you see the words within the circle. Sometimes they get written outside. Right? So we might have like animals written just above the circle, and then sometimes you also may see that, but with an arrow pointing to the circle. Right? So it's kind of understood depending on context, and you have to see based on the source that you're looking at what is indicated there. Okay, so then we've shown that there could be some overlap between animals and things with tails, but our statement is going a little bit further than that. It's saying that some animals are things with tails. There are some members of the set animals that are also members of the set things with tails. Right, so this is where we use an X to indicate that, right? And we just want to show that there is something in that overlap there. There is an animal with tails. All right. This verse, Romans 3:9 specifically, we could represent this with a Venn diagram, and there are a number of different sets mentioned here. So if you read through this, you can see how many different sets we might have to represent this. Right? So the verse reads, "What then? Are we Jews any better off? No, not at all, for we have already charged that all, both Jews and Greeks, are under sin. As it is written, none is righteous, no, not one. No one understands, no one seeks for God." Right? So I'm seeing a number of different categories here. We have Jews, we have Greeks, right? And then we have people under sin, or we might say people who are righteous, or people who are not righteous. Right? So one way you might draw a Venn diagram here would be to do three sets, right? And let's think through where we might need some overlap. All right, so certainly let's go let's go with righteous, Jews, and Greeks as the three sets. All right, so we know that the sets Jews and Greeks are disjoint, but typically when you do a Venn diagram with three sets, you do show overlap between all of them. All right, so remember we are just indicating that there may be overlap, not that there definitely is. Okay, so let's do the three sets here, and I'll label these. So you've got Jews, Greeks, and then let's go with people who are righteous. And then it would be understood from context, perhaps, that the rectangle is representing people. Okay. And then let's think about who is where in this, and then is this the best way to represent these sets, or should we kind of move some of the circles around? All right, so we could leave it like this, but if you read what the verse is saying, we know that both the Jews and Greeks are under sin. So they actually, there are no Jews or Greeks here, here, and here. All right, none that are righteous. All right, so we don't want to put X's there, because that would indicate that there are some Jews who are righteous, for example. All right, so I actually don't need any overlap between Jews, Greeks, and righteous. All right, so I might want to modify this a little bit. Right, and then we also know that Jews and Greeks are disjoint, so perhaps we want to do it like that. Right, so if we modify this a little bit with those changes, it might look something more like this. Okay, we would have Jews and Greeks disjoint. I'll use J and G here. Okay, and then righteous would be disjoint from that. Okay, so no Jews are Greeks, no Greeks are righteous, no Jews are righteous. Okay. Perhaps another way to do this is to use a circle for the set of sinners. Right, so instead of righteous, let's do sinners. Right, well, in that case, this verse is telling us that both Jews and Greeks are under sin, and none are righteous. Right, so in that case, we would have, let's see if I can do this. It might be more of an oval than a circle. No, let me redo this one. Okay, so let's do a circle for sinners first. And then we know that Jews and Greeks are both subsets of those people. Okay, so I'll fill those in. And let's keep those disjoint. Okay, and then we would still have people as well. Right, now I guess we could think through too. This would sort of imply that there are sinners who are Jews, sinners who are Greeks, and then sinners who are neither Jew nor Greek. But if in this context, if Greek is just indicating Gentiles or non-Jews, then perhaps we don't want to have like this extra category out here. So in that case, we could even get rid of this category for Greeks, and we could just simply have a circle for Jews. Okay, so then we would have, in here the X would represent Jews who are sinners. Okay, out here would be non-Jews who are sinners, or we could say Greeks, right, who are sinners, right, and then people would be out here, right, and again you could even modify this a bit more. All right, if everyone is a sinner, then nobody's really out here, right? So perhaps we don't even need the circle for sinners. Perhaps we just call this, we can call this rectangle sinners, and then I can even get rid of this circle. All right. So the point of this is that you can use Venn diagrams to show these different relationships. There isn't necessarily one correct way to do this. It's more of just a visual organization tool, and it depends on what facts you're trying to emphasize as to how you make this. Okay, so you can see kind of as you go through, you might have an initial idea of an organization, but as you go, you might decide that a different organization or illustration is better in that case. All right, let's look at one more example of a Venn diagram, and let's see if we can figure out where we could put an X in this diagram depending on some given information. All right, so let's say we know these first two statements. We know that some girls are honor students, and we also know that no honor students are employed. All right, so is there anywhere that we can put an X? Do we know any sets that have members in them? Okay, so boys is the blue circle, right? So that would mean that girls would be in the regions outside of the blue circle. All right, so the girls would be here, 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 and here. Okay, and what we need to do is think through, can we actually label any of those with X's? Okay, do we know that girls are in any of those categories? All right, so we know that some girls are honor students. All right, so out of the places where girls are represented, okay, the ones that are honor students would be here and here. Okay, so can we put an X in either place? Well, this first X, this would be girls who are honor students who are outside of that group of employed people. So those would be the unemployed female honor students. And then this X would be the employed female honor students. Right? And that's where the second statement comes in. We know that no honor students are employed. Right? So there's actually no overlap between the honor student circle and the employed circle. Right? So that means that there's no X here. Right? And then we know that then if there are girls that are honor students, which is what the first statement is telling us, right, then they must be in this spot. They must be unemployed. All right, and then is this enough to answer the question, are there girls that are employed? Right, so what we want to know is, are there any girls, so outside of the boys circle, right, that are employed either here or here? Right? And we actually don't know that. What we know is that that there are some girls who are unemployed. Okay, that would be this blue X, right? But it doesn't mean that there definitely are ones that are employed. They could all be unemployed, and we don't know. Right, so if this is the question, are there girls that are employed? It's unknown. We don't have enough information. Okay, in your reading, another thing you can do with this is think through what happens if you change some of the labels here. All right, so you might want to go through as an exercise and maybe change boys to girls, right? And then see if you can answer some different questions, or maybe see who is where based on this information. You could change employed to unemployed and see what happens there, right? And go through that same exercise.